Hey everybody, this is Mr. Beckstrom, and today I'm going to look at some examples from section 9.1. This is on polar equations and polar coordinates. So in the polar coordinate system, it's going to be quite different than the rectangular coordinate system that we're used to. So let me kind of give you an example here. So with the polar coordinate system, we still have the same kind of XY graph. And you notice here we start here at 0 on the right x-axis or the positive x-axis. And just like a normal angle, we go counterclockwise for positive and clockwise for negative angles, and then we also have a radius. So that's what a polar coordinate is. The second portion here, so the second coordinate here is the angle. So that is the angle that we go starting from the positive x-axis. So in this first case here, you would go pi over 2. So you would go up and you would go in this direction here. And then this second value here, this is the first coordinate in the coordinate system here, would be the radius. That would be the distance that you go from the origin here. So this means that we would go 3 units in that direction, and that's where our point would be. So this is how we kind of graph a polar coordinate. So let's just kind of graph these without really finding the equivalent rectangular coordinate first. So I know that 3 pi over 2 is going to be somewhere up here. And then we're going to have a little bit of a trick with the next one, and I'm going to show you why that is. So this next one here, I start with the angle, so 360. Let me erase the last one. 360 tells me to go all the way around in a complete circle. So I am pointed in this direction, and it tells me to go -4 units in that direction. But negative actually means in the polar coordinate system to go the opposite direction. So instead of going to the right, we're actually going to go 180 degrees away, which is in the exact opposite direction. So I'm actually going to go 4 units in this direction. So I would have a point that would be somewhere over there. So that's what a negative radius. So this negative radius tells me, it says whatever direction my angle is pointing in, I'm actually going to go in the direction that's 180 degrees away from that angle. So you could just either add or subtract 180 degrees from that. In this case, if you take 180 from 360, you'll get 180. So I'm going to go in the 180 degrees direction for 4 units. All right, and then the last one here, let me erase some of this here. And it says 10/26 pi over 3. So with this one here, we really need to first figure out what direction is this 26 pi over 3 going. And for that, we can go ahead and use what? All right, we're going to go ahead and use coterminal angles. So I notice that I can add or subtract multiples of 2 pi until I get an angle that is between 0 and 2 pi. And then I can figure out what direction that is. So if I start with 26 over 3, 26 over 3, and I'm just going to leave the pi out and I'll add it back in at the end. And I keep subtracting 2. Remember, I'm trying to get a value that is between 0 and 2. So -2, -2, -2, and one more time. So there's my value that's between 0 and 2, and then I can convert that by hitting math, fraction, enter. So that's 2 over 3, and then I can put the pi right back in. So this is going to be equivalent to the coordinate of 10, 2 pi over 3. And hopefully I know that 2 pi over 3 is in this direction right here. So we're going to go in that direction 10 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So however far 10 units would be, that's where this point C would be. All right. So that gives us kind of a visual kind of demonstration of where these points would be. But let's see how we can actually convert these to regular coordinates. And let's go ahead and start with C, since this is the one that I have here. So we're going to basically be using two formulas. We're going to be using x is equal to r times the cosine of theta. And we're going to be using y is equal to r times the sine of theta. All right, and so for this first one here, or C that we're starting off with, my x coordinate would just be equal to r, which is 10 times the cosine of 26 pi over 3. And that's just equal to 10 times, remember, 26 pi over 3 is coterminal with 2 pi over 3. And the cosine of 2 pi over 3 is negative 1/2. So that's negative 1/2. So this would just be negative 5. So that's the x value there. So this would be negative 5. And then the y value, our y value would just be 10 times the sine, our sine theta, of 26 times pi over 3. And that's just going to be 10 times the sine of 2 pi over 3, which is the square root of 3 over 2, square root of 3 over 2, and that's just going to be 5 times the square root of 3, 5 times the square root of 3. So that is going to be our coordinate, our rectangular coordinate that is equivalent to the polar coordinate 10, 26 pi over 3. All right, let's take a look at the other ones. So for 3 pi over 2, pretty easy here. So we're just going to do x is equal to 3 times the cosine of pi over 2. And that's going to be equal to, so pi over 2 is straight up. And the cosine of that would be the x value there. So that's going to be 0. So this is just going to be 0. And y is equal to the 3 times the sine of pi over 2. The sine of pi over 2 is 1. 3 times 1 is 3. So a is going to be 0, 3. So a is 0, 3. And then the last one, negative 4, 360, same thing. X is equal to negative 4 times the cosine of 360 degrees, which is equal to, the cosine of 360 degrees is 1, so this is just negative 4. Let me double check that. That looks right. And then y is equal to negative 4 times the sine of 360 degrees, which is equal to negative 4 times 0, which is 0. So B is going to be negative 4, 0. That's it. That's it. So hopefully it's not too bad. And if you have any questions, let me know. And I hope you have a great rest of your week. Thanks.